Hello everyone, now in this video we will talk about what will happen if we have two wires parallel to each other. Now let's say this is wire A and this is wire B. We can say the wire A are producing a magnetic field because there is current in it. Now we will use the right hand grip rule to determine the direction of the magnetic field. Okay, the thumbs will follow the direction of the current while the other finger will determine the direction of the magnetic field. We can look this at the wire B is in the region of the magnetic field produced by wire A. So we can say wire B should interact with the magnetic field produced by wire A, and as the result there will be a magnetic force experienced by the wire B towards wire A. Now we need to determine the direction of the magnetic force experienced by wire B. We will use another right hand rule where we say right hand palm rule, where the four fingers will represent the direction of the current and the palm will represent the direction of the magnetic field and the thumbs will represent the magnetic force. Now let's look. This is current, so we put it like this, and the magnetic field outwards, and we can see the magnetic force will go into rightwards. Wire B also produce a magnetic field, so we will use right hand grip rule. The currents go upwards and the direction of the magnetic field we see here will go into the patch, while here out of the patch. The wire A is in the region of the magnetic field produced by wire B, so we can say the wire A will interact with the magnetic field and experience a magnetic force. Now, by using right hand palm rule, we will determine the current of the wire A is facing upwards, while the magnetic field is inwards into the patch. Now, we will see the magnetic force will go at the leftwards. Therefore, the wire A is experience a force go to the left, while the wire B experience the force go to the left. And in conclusion, we can say both wire will experience a magnetic force that go towards each other. As the result, both wire will attract each other.
Okay, so now we will be deriving and explaining the equation used to determine the magnitude of magnetic force experienced by a current carrying conductor interacting with the magnetic field produced by another parallel current carrying conductor. As you can see here, this is FAB and this is FBA. FAB stands for magnetic force acting on A by B, and FBA is vice versa. As you can see here, let's go to the derivation of the formula of magnitude of FAB over LA. As you can see here, this is FAB and this is BB. Okay, FAB is already informed, while BB is known as magnetic field produced by B. Okay, let's combine both of this equation into one, which will turn into this. If we further derive it, this will be the end result. And then let's go to the derivation of magnetic force over length for FBA. You can see here, this is the equation for FBA and this is the equation of BA. We will combine both of this into this, and then we will further derive it and finally get this as the end result. And if we compare FAB over LA and FBA over LB, we will notice that it has the same derivation. So we can conclude that FBA over LB is equal to FAB over LA.